is lesson 3.2 on adding and subtracting polynomials. When we add and subtract polynomials, what we want to try and do is we want to group the things that are identical together. So we're looking at the sizes of the objects. So we have different sizes of objects. Sometimes that's a good thing to draw them above the digit. So this guy here, I've got big squares. This guy here is little squares. These guys are big squares. These guys are sticks. And these guys are baby squares. So we can just looking at the objects, you can tell right away which ones you can group together. Okay? So what I would do is, your workbook shows you the big one going underneath the small ones. Meaning the trinomial, more terms, is on the bottom. More terms is better to put on top. So I would do the reverse order of what the workbook did. So I'm actually going to take this guy and match him under the other guy. So I'm going to match the big square to the big square. So negative 2x squared, I'm going to write underneath him. And then the negative 4, I'm going to write underneath the little squares. Okay? So I took it all the way from right here, and I wrote it underneath the object that it matches. Okay? Now all you do is add straight up and down. So I have 3 and negative 2 gives me a positive 1, x squared. There's nobody to add to him, so he just slides down. And then these two we have to add together to give us a negative 2. Okay? They get the exact same answer, but what they do is they put the big one on the small, underneath the small one. It's hard doing that because you need to spread them out because this guy's in the middle here. He has to slide down in the middle. Okay? Alright, so this is the adding vertically and grouping like terms. So, this is the same one, and this is again doing it this way. So I'm going to do it the opposite way. I did the adding vertically right here. What I'm going to do on this bottom part is I'm just going to group them according to color. I'm going to color the same objects. So if I had a highlighter, I might say, okay, I'm going to take those big boxes, big squares, and I'd highlight them. So I would add those together. So using colors really helps. You could also use shapes. So maybe I wanted to use a triangle over the ones that don't have variables. I could group them that way. And then I would find out, oh, this guy here, he didn't get grouped with anybody. So that means there's nothing to add to that one. So that one's going to get put where? In between them. So we're going to add those guys together, the ones that I colored in green. We get 1x squared, just like we did up here. And then the guy that doesn't have any buddies is going to slide in the middle, negative 2x. And then I'm going to add the triangle ones together. Negative 4 plus 2 gives me a negative 2. So there's different ways you can group them. If you like colors, colors really do help. If you like shapes, you can use shapes. Okay? Or a combination of both also works. All right. Now we're going to see how do we do it with the algebra tiles. So they show you this. Okay, so what they've drawn is they've drawn these tiles here. They've drawn the other tiles there. Why do you think they use brackets? If you were here on the snow day, you know what kind of brackets these are called. These are called specific brackets. It starts with the letter S. Who remembers what they are? No. Size brackets. Size brackets, yeah. Okay? The reason they're a size bracket is all they're doing is they're just showing that this is a binomial. Okay, 2 terms, they grouped in brackets to say, hey, that's a binomial. That's why they did it. And this one here is a trinomial. That's why they grouped it in brackets. Okay, they want to show the different sizes of the polynomials. So what we would do is if we're dealing with the squares, we would now start crossing off the ones that are the opposite colors, because that's called a zero pair. So I would start taking off 2 white ones for 2 shaded ones. 2 more white ones for 2 more shaded ones. And then I could take, let's see here. Oh, this is just rearranged. And then now I've got 2 little baby shaded ones. I can take my baby shaded ones. And then I circle what I've got left over. So what I have left over is an x, like the x squared big box, and then 2 sticks. And 2 little baby guys right there. So that's what we have left over. So we draw what we have left over right here, and then we write it in symbols and numbers. symbols and numbers, okay? So variables and digits, that's the symbolic form, okay? This is the polynomial form, this is the symbolic form, okay? Symbolic meaning you're using numbers and letters. Okay, subtracting is a little different. Subtracting uses the idea of tic-tac-toe. So what that means is, in order to remove the brackets, so with subtracting, we look and see what's in front of the bracket. If there's a hidden plus sign there, so we see basically nothing there, then you can take the brackets away right away. So this guy here has nothing in front of him, except for a hidden positive 1 and a plus sign. So I can take those brackets away. These guys, I can't take the brackets away until I change the sign in the middle that's separating them. This negative, I need to change to a positive. But when I do that, the bracket after it is going to change all of the signs. They do the opposite. So this guy is now going to become positive. This guy's now negative, and this guy's now positive. And then what you would do is you would write them under who they match again. So I've got my 2x squared minus 4x, subtract 3, that's my left-hand side. Now I'm going to write this underneath the one they match, okay? Now, x squared becomes a positive. So I've got 1x squared, I'm going to add to that guy. This guy here is a 2x, but now he becomes a negative 2x. So I put him underneath this guy. My 1 at the end now, the negative 1 becomes a positive 1, so plus 1. Now I draw my line, and I add straight up and down. Okay, so you're going to add the digits in front. That's all we're adding always. So whenever we add them, remember we're adding specific objects. These are the giant squares. These are the sticks, and these are the baby squares. So that's why you have to group them according to what size of object they are. After you've done that, the x squared stays an x squared because that's this object. You're not going to add the exponents when you add the digits. You never add exponents if you add digits. Okay? All we do is we say, oh, we're grouping them. How many of those big squares do I have? That's all we're saying. How many big squares? So there's my big squares. I add the numbers in front. I have 3 of them. Then I add the numbers in front of these guys. That's a negative 6, but I got to bring my x with them for the ride because he's those long sticks. Okay? Then I'm going to group these guys together and add them up. So negative 3 plus 1 gives me a minus 2, and that's those baby tiny squares. Okay, so this will be my very final answer. We can go any further. Okay, you're not able to go further unless they tell you what x is. If they say x is 5, solve the answer. Then you put it in for 5. Okay? Any questions so far on the subtracting part? It gets a little tricky, so we're going to do a couple more examples. So let's take a look at the next one. So, this is subtracting vertically. This is what I just showed you. So that's the way I like to do it. I find it easier when I match underneath the object. I think that's easier. So, what do I have to do to this guy? This is the exact same question. All they've done is they've made us do a different strategy. So if I did this one the other way, they said, the other way would be this. Again, using highlighters and colors. So I would group these guys and these guys together. I would group these guys and these guys together. But remember, you've got to remove that negative sign between the brackets. So you've got to change it to a plus, and then everything else after that changes signs. Only in the bracket though. So this guy goes positive, he goes negative, he goes positive. Okay, and then you would add the same things together. So now I would add my things that I highlighted in green. So I have 2 and now positive 1. So that's going to give me 3x squared, those big boxes. Then I'm going to add my sticks, the ones I didn't color. I'm going to color them yellow now. So here's my sticks. So I've got a negative 4, and this positive 2 now becomes a negative 2. So negative 2 and negative 4 give me a negative 6 x's, those sticks. Then I'm looking for these triangles, what I've got in a triangle now, my constants. So we have no variables, negative 3, and this guy now is a positive 1. So negative 3 plus 1 is negative 2. Good, with the squares. So again, you can group them like this with colors or with shapes. But remember, when you're subtracting, you have to change it to adding. So when you change it to adding, the sign in the middle, the brackets after it, always change their signs. So we're going to look at a couple questions in a moment here. Is this the exact same question? No, this one's a little bit different. No, got it. Okay. Now they want us to do with tiles. When we subtract with tiles, this is what they've showed us. So, they showed each of the brackets. What did you notice they did at this point, right here, when they removed the brackets? They changed all the colors. Why do you think all the colors here changed? Right, because you had to switch the signs. You had to switch that to a positive. This guy then had to go to a positive. These guys had to go to negatives. And this guy had to go to a positive. So they changed colors. So you would just use those with the tiles. Now you just add up the same objects. So you've got 3 big squares, 3x squared. You've got sticks. You got 6 of them now, and they're white. So the white needs the negative 6. Okay, that's the difference there. All right. Now we're going to the notes that I gave you. These are other questions that you're also going to see. Look at all these polynomials. Oh my goodness. We're going to group that together. Okay, this is in that other set of notes. It's on the very first page, the bottom of the first page of that set of notes. Okay, the bottom of the first page. We're going to group these together. But we're going to group them together using colors and shapes. And then we're going to write them underneath the one they match. So, what do I have to do with the sign here? Change it to positive. Now what happens? Tic-tac-toe. We got to change all the signs after. So this guy becomes positive, negative, positive, negative, positive. Okay? So whenever you change the middle to a plus, all the signs after have to change. Okay? So now I'm going to color them to group them together. So, I have x squared big boxes on the left. I'm looking for x squared big boxes. I'm going to see one on the very end. So now I'm going to write this green one underneath that guy. So I've got a plus 1x squared. Okay, I dealt with him. Now I'm going to erase him so I don't confuse him again. Okay, now I'm going to the next one. Who do I see next? Just a single x. So I'm looking for a stick. Who's my stick in here? What kind of 5x? He's a negative 5x now. So this guy is going to match with this guy. So I'm going to write this one underneath that one. So I'm going to write negative 5x under that guy. Okay? I dealt with that guy now. All right. Who's next? The xy. Okay, so I got to look for an xy. Right there. There's my xy. So I'm going to write him under the other guy. So plus 3xy. And I'm going to cross him out because he's used. Now we're looking for the y's, only just the single y sticks. So I've got a single y stick right here. So I'm going to put negative 3y under him. Okay? And my 4y squareds. I'm done with that guy. This guy's going to go underneath him. Positive 4y squared. Okay? Now we're going to draw a line. We're going to add straight up and down. Okay? I'm just going to move this up so people at the back can see better. So now we're just going to add straight up and down. Okay. Straight up and down, we're just adding the numbers in front. 7 plus 1 is 8x squared. We dealt with that guy. Now we're doing the one next to him. So I have a positive 1, subtract 5. Negative 4x. Because you have 1, subtract 5. The next one, how many xy's do we have altogether? 5 xy's. And it's positive, so because it's positive, we have to connect with a plus sign. So plus 5xy. We dealt with those guys. Now we got to deal with these guys. Uh-oh. What do you notice? They're almost the same, but they're opposite signs. If they're opposite signs, what happens? They cancel. They give me 0. Because 3 plus negative 3, or 3 subtract 3, is 0. So that means you don't even write them down. If the coefficient is a 0, that means they disappear completely. You have none left. Now we're just going to add the y squareds. We have a negative 1 and a positive 4. We have to connect to the plus sign. Plus 3y squared. We connect to the plus sign because this guy is positive. If he was negative, we would connect to the subtract sign. Okay? Now, how do we do it? And I've seen a question like this on the achievement test. So how do we write this? And what the question's going to do is it's going to show you the multiple choice answers. And they're going to say which expression shows you how to subtract this the correct way. So we're going to show how to do this. So there's a couple steps we have to do. So we're going to write the steps down. First step is to write all tiles in one bracket in numbers and letters. So we're going to symbolic form. So we change everything to numbers and letters. The second thing we do, after we change everything to numbers and letters, we put a subtract sign and open another set of brackets. And open another set, or just another bracket. All right, and in that bracket, you are going to write what is shown with the arrows. And that's it. Okay, because that's just going to show you how to write the expression. So, first step, you write everything you see in a bracket. Put a subtract sign. Then, everything that's in boxes that's being dragged down with an arrow, that goes in another set of brackets. And that's done. Then you're done. So, this is how we would do it. So, step 1, we write everything in a bracket. So, how many big boxes do I see? 3. So, how would I write that? What do you think, Jay?
3x squared.
Perfect. Okay, 3x squared. What do we see for sticks? How many sticks do we have? Good. So what am I going to write then? 5x. Good. All right. How many little baby squares do I have? How many baby squares do I have?
11.
11. So do I just write 11 and then close my bracket?
Wait.
No, how come? Because that means I'm going to be multiplying it to that guy sitting side by side. What do I have to separate it with? A plus sign. It's a positive 11. So plus sign. Okay? So that's our first step. Just grab it all. There. Put them together. And make them smaller. Okay. So that's our first step. Now we do it says put a subtract sign. All right, we're going to put a subtract sign after it. Then it says open another set of brackets. Okay, opening the other set of brackets. What goes in there?
The rest of them. Or no.
The ones with the arrows. So I'm going to color them in green. These guys and these guys, the ones that are being pulled out. Those are the ones I'm going to draw in here. So, how many big boxes are coming out? 2. So that's 2x squared. How many sticks are coming out? 2 plus 2x. How many baby squares? Okay, plus 4. That's your subtraction sentence. You're done. Okay? If they just said, what is the subtraction sentence that makes, that's what you would do. So whatever's being pulled out goes second. Everything you see goes first. Okay? And how do you do the answer? Yeah, exactly. But how can I do it just by looking at the tiles? How do I know what the answer is if I just look at the tiles?
Just add them.
Sort of. What parts do I have?
All.
Everything you see, that's going to be this bracket.
Yeah, I know. I thought you
So how do
wanted the
I
answer
find
to the
the answer?
Yeah. Wouldn't that be the answer?
Well, this is the answer to writing a subtraction sentence.
Yeah, but
But what if I wanted the answer to that subtraction sentence?
Yeah, wouldn't you just add all the squares up at the top?
That are left over. You would add everything left over. So what you would do is you can see this stuff's left over and this stuff's left over. That would be your final answer.
Yeah, no, but I thought you were wanting
There's what?
the answer for 3x2 plus 5 times 11 minus 2.
Right.
So if you wanted the answer for that, wouldn't you just do all the ones at the top? And then combine.
If you wanted this to be subtracted, the first thing I wanted you to do was
No. If you were like
all we were doing is writing the subtraction sentence. You are correct. We write it all. We're doing the subtraction sentence.
yeah,
Yes.
but I thought you wanted the answer for that.
Yes, this is all the answer would be. But then if I said, now tell me what this gives you if you do subtract it.
Yeah, I was saying if you just add all.
You're right though, but you should add one more word to that. It's what's left over. So you add everything left over. So what I have circled. So you've got one big squared left. So you have one big x squared left. That's this guy. You've got 3 sticks left, so plus 3x. And then we've got 7 little babies left, so plus 7. So this is what's left. And if it's a multiple choice question, and they say just write down what the sentence is, the subtraction sentence. All they want is the first part. They don't want the answer. So if you see the answer written somewhere, they don't want that answer. They just want to know what you would have subtracted. But if they say solve it, they do want the answer. Okay? So it depends on what the multiple choice question says. All right. When do we know it's in simplest form? It is in simplest form when your algebra tile model uses the fewest tiles possible. Symbolic form means the numbers and letters contain only one term of each degree. Okay? So there's going to be only some x squared, only some x's, only some constants. That's what that means. And then it says when you don't have a zero coefficient. Because sometimes things subtract, just like those 3 y's did in that one question, they were gone completely. So sometimes they completely disappear, and that's okay. So we often get unknown shapes that they're going to ask us to solve for. And perimeter is the adding and subtracting part. So we want to do perimeter of an object. And if they tell us perimeter, but they're only giving us one side, we need to figure out the unknowns. The only way to figure out the unknowns is to take a look at this, and we are now going to label everything we know about this. If they've got one tick here and one tick here, what is that telling me about these ticks right here? Right, those sides are the same length. Nope. Yep. Okay. Hang on. You're almost done subtracting. So I'm going to put 4 r's, because there's a 4r down here plus 4. So now we've got to count how many r's I've got. I have 4 here and 4 here. How many is that? 8. And it says I need how many total? 10. So then how many should I put on each side? 1. So I have an r here and an r here. That gives me my 10 r's. Okay, what's happening with my digits? Let's check my digits. I have 12 I need total, and I've got 4 here and 4 here. How many is that? 8. How many are left over? 4. I need to split it with both sides. So how many go to both sides? 2. So we'd have r plus 2 on both sides. Okay, r plus 2. So we found the unknown side. Our unknown side is r plus 2. Okay? So when you're doing stuff like this, label everything you know and then work backwards. That's what that's about. Okay? All right, one last slide. Here we go. So you're often going to be given the perimeter, just like we were on that last one, and you know two sides, you got to find the unknown side. So what are we going to do with that? Well, we're going to take our total, the perimeter, and we subtract the other two sides. So I was going to subtract the other two sides. What I did was I added these guys together, and now I'm going to subtract vertically. Okay? So I'd like you to write this part down, please. You should have everyone your page. Turn your page over. Let's go. Okay? Page 7. Top of page 3. Okay, top of page 3. So I added 6 and 6, and that's where I got my 12. I added -3 and -3 to get my -6. And then I added -4 and -4 to get to -8. Okay? Now we have to subtract this. This is in a bracket, and now I've got a subtract sign in front of it. What does that make me do? Because remember, we don't subtract things. We change it to addition. So I need to change this guy to adding. If I change him to adding, what has to happen in the brackets? Everything changes signs. The 12 becomes -12. The 6 becomes +6. And the 8 becomes +8. Okay? So now we're going to add straight up and down. So 15 and -12 gives me 3y squared left. So you have a 15 and a -12. -7 plus 1, or 6. What's -7 plus 6? -1y. Now we're adding the constants. These guys at the end. What's 8 and 2? 10. Beautiful. So now, this is our unknown side that we had found. This guy here, he is the length of the bottom. Okay? That's how we would do that. Now, you're often going to get a question that looks like the box is on the left there. Okay? And all you've got to do is you need to do exactly what we did on the last question. Is whatever's on the top is going to match the bottom. Whatever's on the left side is going to match the right side because it's a rectangle. Remember, rectangles have two sides the same that go up and down, and two sides the same that go left and right. So that means these guys up here, and that's what we do, is we label. Label all sides. That's super important. Not sided, sides. Okay. And this is what's going on here. So if I'm labeling all my sides, that means if I look up top, I have an X up top. I'm going to go to the bottom, put an X down there. Look up top, I have an X. I'm going to go to the bottom, put an X over there. On top, I've got 5 1s. I'm going to put the 5 1s on the bottom. Or 6, sorry, 6 1s. Then I'm going to look left and right. On the right, I've got an X. I'm going to go to the left and put an X. I have another X and another X. I'm going to put X's on the other side. Okay? So now we've gone all the way around our object. Okay? All we have to do now is count the number of X's we have that we see around the outside. So, I'm going to start highlighting them in green and count with me here. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 X's. So we're going to write 10X. Now we have to add the individual ones. We have 6 on the bottom and 6 on top. So what's that going to give us? 12. So plus 12. That is our answer for the perimeter. Okay? That is the answer for perimeter. This concludes the lesson on adding and subtracting polynomials.